humanoid robots.
Yeah.
You know how for years they felt like something straight out of science fiction? Like we saw them in movies.
Yeah.
These clunky metal things or, the super realistic androids.
Yeah.
And it always felt like it was way off in the future.
Totally.
But based on some of the stuff we've been looking at,
Yeah.
it seems like that gap between fiction and reality,
Right.
it's closing
Yeah.
pretty
It's
rapidly.
For sure.
And especially with NVIDIA's announcement of GR00T N1.
Right. And that's a big one.
That feels like
Feels like a huge leap.
a huge leap forward.
Yeah, for sure.
So we're going to do a deep dive today on
Yeah.
what exactly makes this GR00T N1 so noteworthy and why it's got everybody so excited and
Right.
kind of what it could mean for the future based on
Right.
what we've seen. So
It's
let's jump right in.
sure. But at its core, Isaac GR00T N1 is NVIDIA's first open source
Okay.
foundation model that's designed specifically for humanoid robots.
Okay, so
Like-
how does that work?
So to kind of put that into perspective, think about how those large language models
Yeah.
like ChatGPT and all
Yeah.
that have just completely revolutionized the way that computers understand and generate human language.
Right.
GR00T N1 is kind of aiming to do something similar for robots.
Oh, okay.
So instead of just processing text,
Okay.
it's designed to understand language,
Right.
but also visual cues,
Okay.
and to be able to reason about tasks.
So it's taking all of that information
Right.
and putting it together to be able to actually operate more on its own.
Exactly. So it should give
Okay.
robots a much greater degree of autonomy.
Okay, so instead of just having like pre-programmed instructions.
Yeah, just following a script.
Yeah.
This is about letting them figure things out
Yeah.
on their own.
Okay,
In a way,
got it.
to a certain degree.
So like if it saw an object that it's never seen before,
Right.
it wouldn't just like stop.
Yeah, the traditionally programmed robot
Yeah.
would just completely freeze.
Yeah.
But this one would actually be able to
Yeah.
use what it's learned and, potentially have its function described to it
Right.
and then reason, okay, what am I supposed to do with this thing?
Interesting.
And that's
Like, almost like
yeah.
they're trying to give robots
right.
more of a general intelligence
Exactly.
than just very specific programming.
Yeah.
Cool.
It's a big shift.
Now, I know that
Yeah.
one of the things that they talk about in the material is this two-system approach
Yeah.
inside BRT N1.
Right.
And it almost sounds like how we as humans think.
Right. They're kind of mirroring that.
Yeah, so how does that
Well, so
work?
there are two systems
Oh,
that
no.
are connected.
Uh-huh.
The first one is often called the action model or fast thinking.
Okay.
And that's the one that's responsible for like quick reactions based on visual input.
Oh, so that's the one where,
Like if you see something falling,
yeah, you just like,
you put your hand out
you just catch it.
without thinking about it.
Yeah, you don't think about the trajectory.
That's an action model.
So how do they
That's like trained on
train that? Yeah.
huge, massive amounts of data,
Yeah.
both from real-world robot movements and simulated ones.
Oh, wow.
So it can really learn
Oh.
to react quickly.
So is that like, I'm trying to think of I
Yeah.
know that there are a lot of different like
Right.
neural network architectures.
Right.
Is that something like what's used in
I think so, yeah.
like
Sort of
reinforcement learning?
reinforcement learning where you have to make decisions quickly.
Yeah.
Yeah. It's probably similar.
Okay, cool.
So that's like the fast one.
Yeah, so that's the gut reaction.
Yeah.
What about the like strategic one?
Right. So that's the second system.
Okay.
And that's called the vision language model.
Okay.
And that's the one that's more deliberate.
Okay.
So it's responsible for reasoning, planning,
Yeah.
making those more complex decisions.
Okay.
It's like when you're sitting there trying to solve a puzzle,
Yeah.
you're really analyzing it, thinking through all the possibilities.
Right. It's not just
And this one processes both visual and linguistic information
okay.
to really understand the situation and then come up with a plan.
Interesting.
And so the interplay between these two systems
Yeah.
is really what makes these robots so sophisticated.
That's really cool.
Yeah.
So it's got the gut reaction, but it
Yeah.
also has the strategic thinking
Yeah, exactly.
working together.
Yeah,
That's really neat.
it's cool stuff.
Now, I know that to train a system like that, it must be incredibly complex.
Oh, yeah, it's a huge
Yeah.
undertaking.
And they talk about using Isaac Sim and Omniverse.
Yeah.
So what are those and why are they so important?
So this is a really critical part of their approach because, training a robot in the real world has a lot of drawbacks.
Yeah, like it could break stuff.
Yeah, you could damage these expensive robots.
Yeah.
And so NVIDIA's solution really leans heavily into the power of simulation.
Okay.
So Isaac Sim allows them to create these
Uh-huh.
really detailed and really accurate 3D virtual environments.
So they can just run
Right.
simulations, basically.
Yeah, basically it's a virtual training ground. So
Yeah.
they can generate tons of data by having these virtual robots do, tons of different tasks.
Okay. And they can make all kinds of mistakes.
Yeah, they can mess up.
And it doesn't matter.
It doesn't cost them anything, and they're not breaking anything.
That's really cool.
Yeah, and Omniverse is kind of the platform that enables all that.
Okay.
So think of it as an environment where all the different parts of the simulation can interact realistically.
Okay.
So like the physics,
Yeah.
the sensors, the AI models,
Mhm.
they can all work together seamlessly.
Yeah, that's super important.
Yeah, it's really important.
Because then you can take what they've learned in the simulation
Exactly.
and then apply it to the real world.
Yeah, and that's what they do. They take those models that have been trained in simulation.
Yeah.
And then they deploy them on actual physical robots.
Right.
But then they fine-tune them
Right.
based on what they're experiencing in the real world.
Yeah.
So that bridge between virtual and physical.
Yeah, that's got to be so critical.
It's really crucial, yeah.
Yeah.
And Omniverse really helps with that by making sure that the physics and the sensory data in the simulation are as realistic as possible.
Okay.
So it translates really.
So you can build a good foundation.
Yeah,
And then you can refine it.
exactly.
Okay, so we've got this advanced AI,
Yeah.
we've got these really sophisticated simulations.
Right,
So what does all this mean for, everyday life?
right.
What kind of applications are we going to see?
Well, the potential applications are
Yeah.
pretty wide-ranging.
Okay.
I mean, one of the most obvious ones and the one that people are most excited about is home assistants,
Okay.
right? I mean, imagine robots that can just do your chores.
Oh, yeah, that would be great.
Clean your house, do your laundry,
Yeah.
maybe even cook for you.
Oh, man, sign me up.
Right, and we know that companies like 1X Technologies are already using GR00T N1
Oh, wow.
for robots that are designed to do these things.
Really?
So it's not that far off.
That's amazing.
Yeah, and think about all the challenges of having a robot navigate a cluttered house.
Oh, yeah.
Identify different objects,
Yeah.
and GR0T N1's vision and language understanding could be a big part of making that work.
That's really interesting.
Yeah,
So it's not just, making our lives easier at home,
right.
but what about, other industries?
Yeah, well, think about industries where there are a lot of repetitive tasks.
Okay.
Things that are physically demanding or even dangerous,
Yeah.
like manufacturing,
Yeah.
logistics, warehousing.
Right.
These are prime candidates for this kind of automation.
Yeah, because robots could work 247.
Right. They don't need breaks.
They don't need breaks.
They don't get tired.
Yeah.
And so you could see
Huge gains in efficiency.
huge gains in efficiency and productivity. Yeah.
Right.
And we're already seeing some of this. I mean,
Yeah.
we didn't get into the specifics of which companies,
Right.
but we know that there are companies out there that are already using
Yeah.
advanced robots for things like assembly packaging,
Yeah.
moving goods around.
Right.
So GR0T N1 is really taking us closer to even more adaptable and even more capable machines.
Yeah, it's not about replacing humans.
Right.
It's about
It's about freeing them up
freeing them up to do more.
on those boring tasks,
Right,
the
exactly.
dangerous tasks.
And so what about
Yeah.
fields like healthcare?
Yeah, so that's a really good point.
Yeah.
How can this technology support humans
Yeah.
in these critical fields?
Right.
So in healthcare, you could imagine robots assisting nurses,
Okay.
with routine patient care tasks.
Yeah.
They could help deliver medications and even provide companionship for the elderly.
Oh, wow.
And that ability to understand and respond to natural language
Yeah.
could be really helpful in those interactions.
Yeah.
So it feels more natural to interact with the robot.
And what about applications not just here on Earth, but other places?
Yeah, absolutely.
I know we were reading about,
Yeah, think about space exploration.
Yeah.
Or disaster zones.
right?
These are places that are really dangerous for humans.
Yeah.
So robots equipped with AI, like 00T N1,
Yeah.
could be sent to do exploration infrastructure inspections,
Okay.
search and rescue.
Yeah.
And we wouldn't have to risk human lives.
Wow.
Yeah.
Right.
And similarly, they could work in hazardous industrial settings like
Yep.
nuclear facilities
Yep.
where we really want to limit human exposure.
It's like extending our abilities to be able to do things that we
Right.
couldn't do ourselves.
Exactly.
That's really cool.
Yeah, it's pretty remarkable.
So looking ahead,
Yeah.
what kinds of advancements do you think we'll see?
Well, I think we'll see a lot of progress in a few key areas.
Yeah.
I mean, first of all, I think we can expect to see big improvements in how robots move.
Okay.
They'll be more fluid,
Right.
more natural.
Okay.
GOXT N1 provides the foundation,
Yeah.
but future versions will probably focus on making them even more human-like.
Right. So less robotic and more like us.
Yeah, and that's really hard to do. I mean, replicating the nuances of human movement.
It's incredibly complex.
Yeah, it's super complex,
Yeah.
but that's an area of active research.
Okay.
So I think we'll see a lot of progress there.
So beyond just the movement.
Yeah, and then beyond the physica movement, we'll
Yeah.
see improvements in AI and learning capabilities.
Okay.
The idea that robots could learn new skills
Yeah.
just by watching something,
Yeah.
maybe even watching videos.
Right.
I mean, that would be huge.
That would be incredible.
Yeah, because they could adapt
Yeah.
to new tasks and new environments without having to be reprogrammed
Right.
every single time.
And what about the more practical side of things? Like, will these ever be affordable?
Right, so that's a good question.
Yeah.
I mean, right now, these kinds of robots are super expensive.
Yeah.
But as the technology improves
Yeah.
and as production scales up,
Right.
I think it's reasonable to assume that they'll become more affordable.
Okay.
And some of the stuff we've been reading even suggests that in the next 5 to 10 years, we could see these robots becoming much more commonplace.
So they would be everywhere.
Yeah, potentially.
That's really interesting.
Yeah, it's an interesting thought.
So to sum up,
Yeah.
GR00T N1 is a
Big deal.
really big deal.
Yeah.
It's a step forward.
Yeah. A big step forward for humanoid robots.
Yeah. And it's not just about building robots that can walk around.
Yeah, it's
about building robots
giving them intelligence.
that can understand
Yeah.
and interact with the world
Yeah.
in a real way.
In a meaningful way.
Yeah.
Yeah.
This is
It's amazing stuff.
amazing stuff.
It really is.
So what are your thoughts on this?
Well, I mean, it really makes you think about where all this is going.
Yeah.
What are the implications of this technology? I mean, what are you most excited about?
I think it's all fascinating.
Yeah, it is.
It's all really exciting.
It is.
And if you're interested in learning more about this,
Yeah.
the material we were looking at on
Ah.
the website Pacific Sphere,
Oh, right.
you can find more information there.
Yeah, I think they have some really good breakdowns.
Yeah.
Of
So
the
just
technology.
check that out if you want to learn more.
Yeah. And, the emergence of technologies like GR00T N1
Yeah.
really highlights how quickly things are moving.
It really does.
And we really have to keep learning and
Yeah.
adapting to these changes because they're going to shape the future.
For sure.
And it's a continuous process of
Yeah.
learning and discovery.
Absolutely.
Yeah,
Well, this was a really fascinating deep dive.
it was.
I really enjoyed it.
Me too.
I learned a lot.
Yeah, it's amazing.